So inserts of membrane proteins inside the endoplasmic reticulums. So there, as you can see, there are 6 different types, but actually there is now a type 1 to 3, a tail anchor protein, a multiplex type 4, and GPA anchor protein is found to be in endoplasmic reticulum membrane. So let's start about type 1. So the cytosolic part is carboxylic, and the N-terminal having producing a cleavable signal sequence towards your endoplasmic reticulum lumen site, that is your ectoplasmic space. So what is the structure is simply indicating? A carboxylic terminal towards your cytosol at 8 single-pass transmembrane proteins in between, having a stop transport anchor sequence of hydrophobic regions to be combined with the endoplasmic reticulums, and a cleavable signal sequence having N-terminals region towards the ectoplasmic space is a type 1 type. The best example to be memorized is the growth hormone receptor, influenza, and the LDL receptor. Well, let's talk about the type 2. Before going to discuss about type 2, what's the basic difference? As you can see here, there's the no cleavable signal sequence is there, and another single difference is that the amino terminals or N-terminal region is towards the cytosols, and the carboxyl terminal is towards the ectoplasmic phase. This is the basic difference. And what are the locations of this type is your mainly in your Golgi cells transferase, Golgi galactosyl transferase, and transferrin receptor, and also ACL like protein receptor. But whatever, it's cytochrome 450 as an example of type 3. And in case of type 3, as you can see here, the carboxyl terminal is towards the cytosols, and the N terminal is towards the endoplasmic lumen, lumen. And this is similar to that of the type 1 type, but here the distinct difference that there is also no signal sequence to be get clipped. And if you talk about the tail anchor is just opposite to that of the type 3, but similar to the other type 2. So as you can see here in the diagrammic representation, the type 1 is nearly similar to type 3, and type 2 is nearly similar to type 4 in their direction of N terminal and carboxyl terminal. If we talk about an example is here, you can find the V snare and T snare. And in case of type 4, you can find the carboxyl terminal towards your cytosolic region, and the amino terminal is towards your endoplasmic lumen site. And it is similar to type 1, but it's different that it has a multi number of transmembrane, multi-pass transmembrane protein. Having the important thing here is that this possesses a alternate form of subsequent of your stop transport anchor sequence and a signal anchor sequence. That's the important thing. And this is the GPA anchor protein molecules having N-terminal towards your endoplasmic lumen, and the N-terminals get attached to a GPI. That means the guanylyl phosphatidylinositol is anchored with that protein molecules found in the plasminogen activity receptors. And this is the thing. This is how type 1 is being preferred, and similarly that of the protein synthesis. But here signal peptide enzyme clip the incoming nascent polypeptide chains to get inside the endoplasmic lumen, and the signal sequence clip that the signal sequence of N-terminals, and the stop transfer anchor sequence get attached when bind the translocal region. It get laterally diffused because it does not possess any hydrophobic positively charged region inside it. This is type 1. And if you go on type 2 type, it is, we will find that in case of type 2, type 2, here the positively charged region is found having a signal anchor sequence where they get anchor after getting inside by means of translocon and SRP receptor as that similar to protein sorting, and it's positively N terminals towards your cytosolic region. This is much, and it's type 3 types. You can find the positively charged N terminals towards the endoplasmic lumen, and the positively charged is coming inside, but the direction is remains same. This is because the difference in their terminal because this is the positive charge residue on the C terminals side of the signal anchor sequence called the transmembrane segment to be oriented within the translocon within the C terminal portion towards the hydrosol and the N terminal end in the ER lumen. That means it's simply telling us that the positively charged region is inside. After getting inside of this translocon, it's get inverted to be bound with the SRP receptors, which later on being folded like that means here the signal sequence, like in type 1 there is a signal sequence to be get clipped, but here the signal sequence is not there, rather the signal sequence is intermediately present in the amino acid and this must not be clipped. So that's why when it comes, so the SRP receptor, when it gets bind with that SRP receptor to be bind with in presence of SRP, it's get attached, and then after the synthesis of protein occurs, that's why it looks like this. I mean, the orientation is different from that of the type 1 and type 3. But in case of type 3, though it doesn't possess any signal sequence like in type 2 to be get clipped, but it possesses this hydrophobic region having positively charged amino acids towards your N terminal. That's why rather than that of the carboxyl terminal as in case of your type 2. That's why it's the opposite that of your type 2. So this is very difference and difficult part to understand here, which is I can simplifiedly tell you. Here's the type 3. I mean not type 3, sorry, it is your tail anchor protein molecules. As you can see that they get 3 protein which helps to bind the carboxyl terminal, having a hydrophobic C terminal tails to be get attached to be get inside those endoplasmic membrane, and as is a tail anchor, so its carboxyl terminal is towards your hydrophobically membrane of reticulum and the N terminal is towards your cytosol. So this is your tail anchor, as I've told you earlier. This is the amino groups carboxyl terminal just tip of the brain, which is tail anchor, which is base and T node, and this is multiplasmic G anchor. Now this is the important part in this diagram. As you can see that comparison between type 1, type 2, type 3 and type 4, and the thing that we here memorize that the do this thing, this is internal stop transfer anchor sequence STA and internal signal anchor sequence. In both the cases there are the hydrophobic positively charged amino acids are there in the intermediate region of the protein molecules. That means the positively charged amino acids are there. As you can see, high density of the positively charged amino acids positive on the N terminal side of the type 2, where it is present in C terminal of the type 3. But the thing that you can clearly understand this from this diagram, that it is a type 1 type. Forget about this, you just put the single STA molecules in the type 2 means the type 1. So type 2 and type 3, this is a basic difference you can understand here. So here both the case is contain the SA, the internal signal anchor sequence, and this signal sequence possesses the positively charged positive charge part. As you can see, this positive charge part is towards facing towards cytosols, no matter what is their N terminal or carboxyl terminal. It's only matter with that the positively charged amino acids must be towards facing the cytosols, and this is the hydrophobic region is there. So in case of type 3, as you can see here, the positively charged, so it is towards the cytosolic region. That's why it doesn't matter whether it's positively charged, I mean whether it is N terminal or C terminal. Just the only thing that depends upon here is that the positively charged must be towards the cytosol. Here are the cytosols, positive charge, and here the carbon terminals is here, just opposite to that of the type 2 and type 3. The C terminal and N terminal is different. So that's the this is the two basic things. That's one in that the positive charge it must be present towards the cytosol region, and the carboxy group and amino group doesn't matter wherever they're there. Okay, so in the type 4 you can see that multiple numbers are present, and all in all the cases The positive charge is towards facing the cytosols, where the lumen side there is no positive charge amino acids. And the stop transport anchor sequence never possesses the hydrophobic region in the positive charge amino acids, but consists of only the hydrophobic region. But in case of a single anchor sequence, it possesses both the hydrophobic with positively charged amino acids towards anterior towards the distal cytosol region. This is very different. Thank you very much. Hope you guys enjoy this video.